Okay, this video is for the last of our 3 gas laws. It's called the Gay-Lussac's law. This is a French scientist, and this is his law, Gay-Lussac. And if hopefully you recall that the previous laws, one had pressure and volume, one had volume and temperature. This one has pressure and temperature. And this relationship's real simple. P1 over T1 equals P2 over T2. And what that means is, okay, at a constant volume, so V is constant, all right? V is constant. We know that pressure and temperature have a direct relationship, which means if I increase the temperature, the pressure will also increase, all right? A couple things to keep in mind. Pressure units can be anything. They can be atmospheres, kilopascals, millimeters mercury, but they must match. It must be the same pressure unit. If it's not, you have to convert one to the other, okay? And temperature always has to be in Kelvin, which means you take 273 plus degrees Celsius to get there, all right? So constant volume, pressure and temperature move together, all right? One goes down, the other goes down. And units must be consistent, all right? They must match, and temperature must be in Kelvin. A lot to think about, but not things that you can't do. So here's an example. We got a hairspray can with a temperature of 27 degrees Celsius and a pressure of 30 psi. If the gases can reach a temperature or a pressure of 90 psi, the can will explode. To what temperature must the gases be raised in order for the can to explode? So we have an aerosol can, and we're going to see how hot we have to get it to make it blow up. Not something you should do at home, but something to consider, right? We're assuming constant volume, so that means we can use Gay-Lussac's law. P1 over T1 equals P2 over T2. Now, our pressure 1 is 30. Our temperature 1 is our 27 Celsius. Our pressure 2 is the 90 psi. And so we want to know T2. So first thing is look at our units. Our pressure units are both psi, so those are consistent. So I can go ahead and put those in. So I can say 30 over equals 90 over. Now my temperature unit has to be in Kelvin. It's in Celsius, so I have to take 27 plus 273, okay? And this is going to work out to be exactly 300 Kelvin, so it's 30 over 300. And I want to solve for x. And once I'm there, I can just cross multiply. 30x is equal to the same as 300 times 90. So I'm going to go 300 times 90, and I get 27,000. Divide both sides by 30, and I get 900 Kelvin. Now 900 Kelvin, if I subtract 273, gets me to 627 degrees Celsius. That's pretty darn hot. So if I want to explode the aerosol can, I have to get it awful hot on the inside. Again, I don't know how accurate this is numerically, but you have to get it awful hot. Now, the assignment will be very similar to that. You will have some Gay-Lussac's problems. You'll have some Boyle's law and Charles's law, which you can look at last week's video if you want to review those. And then also you'll have temperature conversions, and that's from last week's video. And also you'll have pressure conversions, which were from 2 weeks ago. So it's a kind of a review on top of the new gas law. Again, if you have any questions, you can check the agenda and see what days we have class. Pop on in, ask your questions. But there's a day each day of the week that you can reach us. Hopefully you're all staying inside. We'll see you when we see you.